differentiate cos 5x from first principles as usual. The derivative of any curve from the first principle, because this is a function of x, so we can say you let y to be the function of x because we've been given the function in terms of x, isn't it? So you say the derivative of a curve is given by dy over dx, isn't it? To be limit as change in x tends to 0 of the gradient. So the gradient is f of x plus change in x minus f of x over change in x. So it means for us to determine this limit, we must get this gradient inside the bracket, isn't it? And for you to get the gradient, you must have 2 points, x1, y1, and another point, x2, y2, isn't it? For you to determine the gradient, you must have 2 points, isn't it? Good. Then from the 2 points, one should be known and one is arbitrary, isn't it? So if you let this first point x1, y1 to be a arbitrary point xy, that is any point on the curve, isn't it? To be a point xy, then we can now start by determining everything. What is the value of x1? x1 we say is x, isn't it? Then you now move, after getting x1, what is y1? If y is a function of x, it implies that y is what? The function of x we've been given is cos 5x, isn't it? So it means y is cos 5x, isn't it? Are we together? So if you let this to be y1, that is x1, isn't it? So it means y1 is cos 5x, x1. If you let it to be y2, that is x2. If you let it to be y3, that is x3, isn't it? Are we together? Good. So y is cos 5x1, which is equals to, where there is x1, put the value of x1 is, you've let to be x, isn't it? Because everything must be in terms of x only as per the formula of the derivative from first principle, isn't it? So what do you get here? You get cos 5x. Where there's x1, you put the value of x1, which is x, isn't it? Then you move to x2. For you to reach x2 from x1, it is x plus that change to give you x2, isn't it? So from x1, it is x1 plus change in x to give you x2, but x1 is x, so it is just x plus change in x, isn't it? Then you move again, what is y2? If this is 2, you put 2 there, isn't it? Are we together? So you have y2 is cos 5x2. So after that, where there is x2, you put the value of x2, isn't it? Are we together? What you are substituting, you bracket. You bracket whatever you are substituting. So you get cos 5, then the value of x2 is the same as x plus change in x, isn't it? Which is giving you cos 5x plus 5 change in, if you take 5 inside the bracket, isn't it? That is cos 5x plus 5 change in x. Are we together? So after getting all these points, so you now go back to your derivative and you substitute them, isn't it? Gradient is y2 minus y1 over x2 minus x1. So you can see x2 minus x1 is this minus this will remain with change in x, isn't it? Are we together? Can you do the substitution? This one is equals to limit as change in x tends to 0 of y2 minus y1. y1 is f of x1, which is the same as f of x, isn't it? y2 minus y1, where is y2? y2 is cos plus 5 change in x minus y1. Remember, if y is f of x1, this is y1 is f of x1, you see? But x1 is what? It's just x, so it means y1 is f of x. So you see, I'm saying y2 minus y1, you see? Are we together? Because you know very well, if this is y2, this is x2. So f of x2, where there is x2, you put the value of x2, x plus change in x, so it means this is y2. Are we together? Good. So what is y1? Cos 5x. Then it is over change in x, which is x2 minus x1, isn't it? You remain with change in x. So after doing that, we've dealt with this. We just grab what we've dealt with. Now we have cos minus minus cos. You cannot deal with that because it means the denominator is for both of them, isn't it? Are we together there? So you have to make it, you have to transform it into multiplication, isn't it? You have to transform it into multiplication. Are we together? So when you have cos minus cos, that means it's the cosine sum and difference angle formula, isn't it? The cosine sum and difference angle formula, because it is cos minus cos. So this is like cos A minus cos B or cos theta minus cos beta, isn't it? So let us start. Cos A plus B is what? Is cos A cos B. If here is addition, the other side is subtraction, isn't it? Then minus sine A sine B. Then cos A minus cos B, the cosine difference angle formula, you get cos A cos B minus plus. If here is minus, the other side is plus, isn't it? Plus sine A sine B, isn't it? Plus sine A sine B. Now we want cos minus cos, meaning we subtract the two equations, isn't it? We subtract the two equations. So if you subtract them, what do you get? Cos A plus B minus cos A minus B, isn't it? Cos A plus B minus cos A. Then on the right hand side of the equation, this minus this is 0, isn't it? Are we together? Then minus into minus is minus, isn't it? Minus into plus is minus, isn't it? So you have negative 2 sine A sine B. Then you start A plus B, you must make to be one thing, isn't it? Meaning this has to be one thing. This, if it is theta, this is beta. Theta minus cos theta minus beta. So this A plus B, you let it be one thing theta. A minus B, you let it be one thing beta, isn't it? So that we now have cos theta minus cos beta, isn't it? So what is theta? Theta, you say, is A plus B, isn't it? Then beta, you said, is A minus B. So if you add the two equations, what do you get? If you add the two equations, theta plus beta on the right, you get theta plus beta on the left. Then on the right, A plus A2A, this plus this is 0, isn't it? Are we together? If you subtract the two equations, on the left you get theta minus beta. On the right you get B minus negative B is 2B, isn't it? You get 2B. Then, if you make A the subject, because we want A and we want B, isn't it? So you divide both sides by 2, you get A to B, theta plus beta over 2, isn't it? Then you get B. You divide both sides by 2, you get B is theta minus beta over 2, isn't it? Are we together? Then now you come and ask yourself, what is your theta? Your theta is 5x plus 5 change in x, isn't it? Your theta is 5x plus 5 change in x. Then what is your beta from there? Your beta is 5x, isn't it? Your beta is 5x. So from there, we want A. What is A now? Is theta plus beta divided by 2. This plus this divided by 2, isn't it? Which is 5x plus 5x is 10. 10x plus 5 change in x over 2, isn't it? Then what is your B? Theta minus beta over 2. This minus this divided by 2, isn't it? What do you get? This minus this is 0. You remain with 5 change in x, isn't it? So there you remain with 5 change in x. Then that one is equals to, you now do the substitution from all this there, isn't it? So this one is now equals to limit as change in x tends to 0 of cos theta minus beta. So you can see this is cos theta minus cos beta. We found is minus 2 sine A, but A is theta plus beta over 2, isn't it? Sine B and B is theta minus beta over 2. So where we have cos theta minus beta, we put its corresponding value with multiplication sign, isn't it? So it is 2, it is negative 2 sine A. But what is A? A you found to be 10x Plus 5 change in x over 2, isn't it? Then sine b. And b you found to be 5 change in x. So from there now, you start substituting. What do you get? This one we dealt with, we can now just rub them. We can now see, we've now dealt with the numerator, you go to the denominator which is changing x, isn't it? Are we together? So that one is equals to what? This change in x is now over one of them only, isn't it? So what is the first thing you do? You take the constant term outside, this negative 2 comes outside, isn't it? So negative 2, then limit as change in x tends to 0 what? This change in x, to put it over, it is supposed to be, we are supposed to have sine y over y. Limit as y tends to 0, sine y over y is 1. Meaning you put it over side with only one term, isn't it? Are we together? With only one term. So here we have negative 2 outside, then sine 10x plus 5 change in x over 2, then times sine 5x over change in x. It is sine 5 change in x, not sine 5x. Sine 5 change in x, isn't it? Are we together? Remember, this is supposed to be y over y. Meaning if y is 5 change in x, this must also be 5 change in x, isn't it? Meaning if you put 5 in the denominator, you also put 5 in the numerator. Are you seeing? Are we together? If you put, so we put 5 in the denominator, we also put 5 in the numerator there. 5 over 5, so that we have 5 change in x over 5 change in x. This is supposed to be y over y. This value must be the same. Have you seen what I've done there? That value must be the same. If here it is 5 change in x, here must also be 5 change in x, meaning you put 5 in both numerator and denominator, isn't it? So what do you get in the end? This 5 in the numerator comes outside. So 2 times negative, 2 times 5, you get negative. You get negative 10, isn't it? You get negative 10, then is there somewhere we've messed? We've messed here. Look at this. This is over change in x. We messed here. When you were substituting 5 change in x, what was the value would be? It was over 2. Severe. It was over 2 because we had b was theta minus beta over 2. So theta minus beta, you go to be 5 change in x over 2. Are you seeing? Isn't it? Meaning this value it was supposed to be 5 change in x over 2. We forgot this, isn't it? It was theta minus beta over 2. Our theta was 5x plus 5 change in x minus beta was 5x over 2. This goes with this to remain with 5 change in x over 2. Are we together there? Good. So you should always be able to identify where you've done the mistake as soon as possible, isn't it? Are we together? Are we together? Good. So from here, this is 5 change in x over 2, meaning if this is y, this must also be 5 over 2. So if you put 5 over 2 in the denominator, you must also put 5 over 2 in the numerator, isn't it? Are we together? So this 5 over 2 comes outside, isn't it? It is a constant. So 5 over 2 times negative 2, you get negative 5, then limit as change in x tends to 0 of what? Of sine 10x plus 5 change in x over 2. The whole of that limit after bringing this one outside to be negative 5, the whole of this limit is always 1 of sine y over y, isn't it? Are we together? Are we together? Yes. It doesn't mean that when this is 5 change in x here also need to be. If you have change in x tends to 0, it is still the same as 5 over 2 change in x tends to 0. Because it is tending to 0. So it doesn't matter whether you divide it or whether you multiply, because it is tending to 0. Are you seeing? Are we together? Good. So this second limit is 1 from L'Hopital's rule, isn't it? So the first limit is now what you substitute. Is that okay? The first limit is what? You substitute. So you substitute, if you remove this limit, where there is change in x, you put 0. What do you get? If you put 0 where there is change in x, what do you remain with? Sine? If this is 0, you remain with the 10x over 2, which is 5? 5x. And you found that the derivative of cos 5x from first principle is negative 5 sine 5x. So the derivative of that from first principle you found is, this is negative 5. If you substitute this limit 0 there, you get sine 10x divided by 2, you get sine 5x. That is the derivative of the function f of x from first principle.